Hello and welcome everyone. I'm Akanksha Singh. I'm the community builder at Be Waste Wise. This is yet another Be Waste Wise webinar this month. And as you all know, we have been organizing such waste dialogues on monthly basis, addressing the need for knowledge dissemination on waste management since 2013. We are a non-profit organization and we have been bridging this waste solutions expertise gap worldwide for over a decade now. And if you see the value in making such diverse sustainability dialogues free of cost and charge to anyone and everyone, then request you all to please support us in our mission. We will encourage you to do check out our website and donate. We will be sharing the link for the donation page and to our website over the chat as well. Now, moving on to the webinar today, the discussion, we will be exploring the pivotal role of Black Soldier Fly, BSF, in managing organic waste and advancing the circular economy by turning organic waste into valuable resources. As you would know that this is a technology which is revolutionary in its own, and if people are not known, then we'll discuss the potential for circular job creation and resource efficiency of this technology, as well as the challenges and opportunities in scaling this innovative solution. To moderate this session, we have Piotrek, who is the Circular Economy Program Manager at Assen Foundation. He has over 13 years of experience in circular economy, and he is also a council member of European Environmental Bureau and a board member of the Polish Zero Waste Association. He is also very much involved in the development of the circular economy in African region as well. Today, he will explore the BSF role in waste management with researchers and practitioners like Dr. Daniela, who is a postdoctoral researcher at the Department of Sanitation, Water, and Solid Waste for Development at EWAC. We have Mwangi, who's the founder of Nutrim Zuri Farm Care and is one of the pioneers of BSF farming in East Africa. And also we have Yuvita, who is a pro BSF founder that specifically offers consultation, training, and BSF site development. Now, before we proceed further to this discussion, I would like you all to know that this webinar is being recorded and will be uploaded on our YouTube channel. Please use the Q&A section for all your queries to the panel and chat function for all the views and, for the networking purposes, your reports, your opinions, all that in the chat function. I would request, please make sure the queries are being passed on in the Q&A section so that we don't lose out on any queries in the web chat. So I would also request all the panelists to please share your LinkedIn profiles in the chat function for the attendees to connect with you personally as well. So back to the panel and over to you, Piotrek.
Thank you very much, Akanksha, and welcome everyone. Yes, my name is Piotrek, and thank you for the introduction. Thank you also for introducing our panelists today, Daniela, Mwangi, and Yuvita. Yes, as you said, I represent the African Circular Economy Network Foundation, which is my main affiliation, and that's why I put on my Tanzanian shirt today. I hope you like it. And also it's true that we have quite a lot of participants from Africa today. This technology is very popular in this region as well. But we also have great speaker and participants from Asia, and so good evening to all of you, and even from Caribbean and South America. So good morning to all of you. And yes, today we will speak about organic waste management, which is by far my favorite stream. And I've been working on waste management for quite some time already, but this one is my favorite. But I got even more hooked into this stream because of the Black Soldier Fly, the BSF, that unites us today at this webinar. So we will speak about this. We will hear from research perspective. We will also hear from the practitioners who are already working on the subject. So as Akanksha said, please ask questions in the Q&A. I will make sure we really go through the questions. We will make it interactive. Introduce yourself. Maybe say if you already do the farm, BSF farm somewhere in the world and where and how big it is. Just introduce that in the chat. Maybe you can also paste links. Before we go to the presentations, I wanted also we prepared a short poll for you. So Akanksha, if I can ask you to put up the poll so that it's a very easy, straightforward question. If we can have 30 seconds for all of you to reply to this. So as a start of this webinar, we will see whether your opinion changed afterwards or the question is whether, according to you, the BSF is ready to implement solution. Not at all. Maybe more research is needed, or actually it is already maybe is ready because the examples show that it's the case. So a few more seconds to get maybe at least how many answers? We have 29 only, so let's get to half of the participants. Please, all participants, just click the answer you wanna see. You feel like it's yours. Numbers of responses still go up, so let's wait a few more seconds. Come on, come on. We are 80 people almost. Let's everyone please click the answer you feel like is most appropriate. Okay, we have 45 answers. I think, Akanshka, we can close the poll. And shall we show? Yeah, let's share the results already with everyone. Okay, so yes, most of respondents think that it is a solution that is already happening. But maybe to make it more effective, more, how you say, optimal also, more research is needed. We will speak about that as well. And interestingly, one person said that this is not a good solution at all. That's if you can also maybe expand your thought or in the chat, that's also interesting to know, so that we can see what are the challenges, and yeah, jointly we can address them, because we are here to answer those challenges, the barriers through research, but also through practical approach as well already. So we can stop sharing. Again, please introduce yourself in the chat. If you already do BSF farm, if you have some experience, small or big, whatever, just introduce yourself. We can this way also matchmake between each other, and yeah, maybe connect through LinkedIn and so on. But yes, the webinar will be about just over 1 hour. Sometime for presentation, we will take questions after each presentation, and afterwards we will have ample time for discussion. If I haven't forgotten anything, I think we can now, yes, move to Dr. Daniela Peguero to introduce the technology to all of us, so that we are all on the same page, and you have a presentation that you can share.
Super. Thank you so much, Piotr. Can you see my screen?
Perfect. Full screen. Great.
Great. Okay, good. All right. Hi, everyone. So as Piotr mentioned, thank you all for attending. I'm super excited to discuss this topic with you all today. My name is Daniela Peguero. I'm a postdoctoral researcher here at EAVAG, and I've been researching BSF for the last several years, working with different substrates. So I'm very excited to discuss this all with you today. So I won't spend too much time. We all know there's a need for organic waste management, right? As we deal with this waste management challenge, and with due to its factor of contributing to greenhouse gas emissions. And in low and middle income countries, we know that organic waste is one of the largest fractions of the waste composition. So really a need to manage this waste. And so most of us, I think, know that there are two really prominent, well-known treatment technologies for organic waste, so composting and anaerobic digestion. But my favorite is, of course, the black soldier fly larvae as one of the potential organic waste treatment solutions. So black soldier fly larvae has really gained increased attention over the last few decades because of their ability to convert organic waste into this high protein, high fat insect biomass that you can use for various applications, such as, for example, aquaculture, livestock, so for pigs and poultry specifically. Pet food is also a potential application. And then they also leave this residual byproduct, which we call frass, that can be further refined and processed into a fertilizer, really increasing soil health. So just in case for those who are maybe not so familiar with BSF, just to give a kind of background on this technology, they were native to the Americas and have since globally widespread, mainly between the subtropic and tropic regions. And this is really because they prefer a nice warm temperature of around 25 to 30 degrees Celsius with a relative humidity of around 60 to 90%. So the life cycle of the BSF essentially first starts with the adult female laying around 500 to 900 eggs. And then these eggs, of course, have a hatching time of around 3 to 4 days where they then enter their larval stage. Now, the larval stage can really take from 13 to 18 days, and this all really depends on the kind of organic waste or substrate that you're working with. So I mentioned that they can grow on a wide variety of organic waste, and some of those are, for example, animal manure, so looking at pig, poultry, and cow manure. Food waste, so anything from restaurant waste to vegetable and fruit market waste, and then milling and brewery side streams. And these are just to name a few of the organic waste. They can also grow on, for example, water hyacinths. And so then towards the end of their larval stage, they go into what we call the prepupal stage, where they start to turn kind of this darkish brown color. And then from there, this lasts around 7 days, and they enter their pupal stage. And so the pupal stage is really where they stop, feeding and use that stored energy that they've developed to then be able to emerge into the adult fly. So their life cycle typically spans around 40 to 45 days. So to give you an idea of what does a setup of a BSF facility really look like. So the idea of a BSF facility really looks at, sourcing your substrate. So whichever organic waste material you're working with, and then maybe preparing that, whether that's, potentially working with a shredder or a mixer to kind of formulate the waste that you're working with. Then you'll then bring this to your waste treatment area where you'll have your 5-day-old larvae and growing on this type of waste. And so many facilities can have their nursery or their reproduction unit already on site. And ideally, what you would want to do is take around 2% of the prepupae that you have to continue this life cycle while you sell the rest of your larvae for products. But yes, so you will treat your waste with the 5-day-old larvae for an extended amount of time and then harvest your larvae. So that essentially means separating your larvae from your waste. And then you can further refine your residue, so you can further compost it, so you can use it as a fertilizer. And then you can separate your larvae and sell it as different products. Now, what that really looks like is, for example, if you have 1 ton of biowaste, we're looking at around 400 kilograms wet mass of residue left over and around 150 to 250 kilograms of fresh larvae. But this is also on a very nice and nutritious substrate. So it's important to note that larvae are just like humans in the sense that they also want something yummy and nutritious for them. The less nutritious it is, the longer it might take, and maybe the less amount of larvae you might have. So just to give you an idea of what these different BSF products can look like, you can either have fresh larvae that you're selling or working with oven-dried larvae, microwave dried larvae, which is a bit more popped, insect meal, so further refining it, and then this residue frass, or you can also have this kind of insect oil. So there's many different products that you can really create out of BSF. Now, one of the advantages with BSF is that you can really have different business models, so really different setups. So for example, I discussed already the centralized. So the idea with the centralized setup is that you have your nursery on site, you treat your waste on site, and you process everything on site. But you can also have a more decentralized setup, right? So the idea with a decentralized setup is that your nursery is not necessarily on site. Maybe you're purchasing your 5-day-old larvae from another facility and using the larvae to then treat your waste on site and then further process it however you determine feasible. So with coming to decentralized, there's different scenarios that you can kind of look at. But of course, it's needed that you have access to be getting the larvae from another producer or facility nearby. So where is BSF happening, right? We hear kind of BSF going on here and there. BSF production at commercial scale we see is already happening worldwide. So this was a study by Stefan Diener and Moritz Gold. It's called the Global Study on BSF Sector. I'm happy to link that in the chat for those who are interested to really get a better understanding of what's the global market and situation on BSF. And so here we can see that, for example, on production at commercial scale, we see that in the US, we have some facilities, already in Kenya, around 8 to 10 number of producers. We see as well as in South America, as well as in Asia. So BSF has really, and of course in Europe. So BSF has really kind of taken worldwide, and there's just many different producers around the globe. However, there's also BSF at a farm scale, and this is also the very interesting aspect. For example, in Kenya, we see over 1,200 farmers are potentially working with BSF, and this is farmers who are either having just crop production or livestock, or even maybe a mixture of both. And we also see in Uganda more than 240, I think even more than 500 have been trained and really adapting and working with black soldier fly. So there's different kind of setups with black soldier fly, and I think that's one of the other advantages is the flexibility of the size that you're wanting to go. So for example, you can work on a more small scale, so maybe on-site farm facility where you want to process about less than a ton of waste per day. So here are some images, for example, from Food Healthy Communities in Malawi and Women Income Network in Uganda. So the idea here is working with more smallholder farmers, a bit more manual labor intensive, but really processing kind of less than a ton of waste per day. Then you can go a little bit further up to the medium scale, so working with processing around 1 to 30 tons of waste per day. And the way this looks can really change depending on how you decide to have your setup. So for example, Bioconvision in Uganda works more with these concrete bioponds, as you can see the image in the middle. So there it's really kind of having more land space and working that way. Or you can work on the more vertical farming aspect, right? So working with the crates and working more in this vertical aspect. And so with the medium scale, you'll have more of this kind of a bit semi-automatic, but also still more manually intensive. And then we see also there's these larger scale facilities, right? So processing up to 700 tons of waste per day. So for example, Protix in the Netherlands, it's a lot more industrial, everything a lot more automized as well as regulated in terms of temperature and humidity control. And so we also see a facility in Vietnam as well as in France. So that's to give you kind of the idea of how different scales of BSF facilities kind of look like worldwide. But there's, of course, important aspects that you need to consider when you're thinking about, right, is BSF right for you? So when we think about this, for example, we've selected 4 different criteria that we think, are really important to investigate when you're determining if BSF facility is the right option as your organic waste treatment solution. And one aspect is looking at the waste availability. Right. So how available is the waste that you're working with, right? Is there a lot of waste in the area? Is it accessible? Are you able to kind of logistically get this access to waste easily? Also understanding what are the different factors that may influence this, right? So is it changing seasonality? As this is one of the factors that really influence your BSF production, right? If we see a huge change in the composition over the year, you're going to see this fluctuation in your production. Also understanding the purity of it, right? Do you need to segregate at your facility? Can it already come already segregated to your site? Then looking at kind of the regulatory framework. So are there legislative barriers and opportunities within your context or within your region? So for example, I can say here in the EU, there are more legislative barriers as we see that, for example, the substrate or the waste that you're working with is very strict. So you can't necessarily work with, for example, post-consumer food waste. And then what is the ease of doing business there? Is it that you have to go through a lot of permits? Permitting also, has a lot of its obstacles as well as high costs associated with that. So is that going to be kind of a difficulty within your region or context? And then, of course, identifying who are the stakeholders that you should be talking to and discussing with. You should also look at what are the market opportunities in your area. So what's the customer perception of BSF products? Are people kind of disgusted by it, or are people more open and flexible and wanting to learn more? What is the market for your products, right? Depending on who your customer is, whether it's a farmer or producer, are they wanting a specific product? Do they want it dried? Do they prefer to have fresh larvae? Do they want it pelleted? There's so many different ways that you can really sell BSF. So it's really important to understand what is the market that people are interested in. And of course, are there market supporting mechanisms there? So can you apply, for example, for a carbon credit financing, and this kind of help ease your availability to get into the market? And then the last important criteria is the operations and management. So understanding the environmental conditions. So this is a biological organism, right? They are very sensitive to temperature and humidity. As I mentioned in the previous slides, they really prefer this ideal temperature of around 25 to 30 and this nice high humidity. So if you're going higher in scale, you might need to try to regulate that. But if you're kind of more on the small scale, do you have these difficulties with these environmental conditions? Also understanding what's your space and equipment available. Of course, with more equipment comes a higher cost. And the last point I want to make there is also understanding your knowledge network. It's super important to really have this network where you can exchange with others and see what were their challenges, what did they find very useful. It's important to kind of develop these skills and these exchange with those around in your area. So I just want to share that we also have a free available feasibility assessment guide where you can really look and see these different aspects. And so there's a scoring system there to really identify, is the BSF facility the right organic waste treatment for me? Because as I mentioned before, there are other obvious organic waste treatment technologies. BSF is my favorite, but it's not always the right choice. So it's really important to understand, is this something that is feasible for me? So I'm happy to link that also later in the chat, as this is a free and available resource. So just to give the main takeaways, BSF can convert organic waste into so many valuable products such as animal feed and fertilizer, as I mentioned before, and it can really be applied at these different scales, right? So small, medium, large, and having different setups. So you can either have your central, where you have everything together on site, or this decentralized system where maybe you purchase the 5-day-old larvae to then treat your waste. And it's really important to consider the different variables, as I just previously mentioned, that influence whether BSF is right for you. So I just also want to highlight some other available resources if in case you're interested in getting to know more about BSF. We have a step-by-step guide that I'm happy to also link in the chat, as well as a e-learning YouTube, where we really go through the different parts of the BSF production chain, the setup of the facility, right? So really understanding what are the steps within each part of the production chain. So the link is here, but I'll also link it later in the chat. And then my last point I want to make is how I mentioned before, this networking and knowledge exchange. We have a WhatsApp community of practice. So together with Piotr, we moderate it. And so you can join different groups. The idea is really more focused BSF within Africa, but we have members from all over the world. And so we have different groups from troubleshooting, so really understanding what are maybe challenges you're having with your facility. And there's experts in there as well who offer solutions. Also funding and employment, as we know that funding is a major obstacle, matchmaking and news channels. So there's the QR code, but I'll also link the WhatsApp link later in the chat. And thank you, and I'm open for any questions.
Amazing. Thank you very much, Dani. Yes, there are a few questions. I will pass them to you in a moment. But just to highlight also something I forgot to say in the beginning, that yes, this webinar is Be Waste-Wise series of webinars. So we take the perspective from waste management. And I love that you started with this, that we have a problem with waste, but there are solutions. And organic waste is probably one of those hollow-hanging fruits where we can deploy different technologies, composting, digestion, anaerobic, but also BSF. So yes, from this perspective, let's start to see also that it is a waste solution, really. But there are also some conditions, and there are a few questions related to that as well. But I also wanted to add that according to environmentalists, we have major problems in the world, that is soil depletion and protein, I would say, provision of proteins. And here again, BSF, we can, thanks to the FRAS, we improve soil quality. Thanks to protein production, which is sustainable, we actually reduce other not sustainable protein productions that are there, like the fish meal or soybean. I also like that you expanded on the centralized and decentralized. We will hear on that from the practitioners as well. And the global market study, also interesting. I think that Maya in the chat has shared the link. So very interesting to see that. I like the photos. Some of them I know, like from Uganda, the bioconversion element. So, okay, I wanted to ask you, so the questions you can also see, I ask every speaker to maybe also answer if you want in the question and answer, but there is one that often happens. I can ask you, so from Susan Edwards. Daniela, are there any worries regarding escape into the local environment and affecting local ecosystems?
Yeah, that's a very good question. So I can speak on it from different points of view, right? So, for example, in the EU, at least also within Switzerland, working with BSF. So as you saw, these large-scale companies, for example, Protex, there is a biosafety level 2 here. So they're not allowed to escape. So, for example, we do have to have double doors and really ensure that they don't escape into the environment. So within Europe, or at least within Switzerland, there is quite strict. You do have to have a permit in order to be able to process BSF. So then abroad, I can say within Uganda, within Malawi, we do have them in the environment, but we do typically anyways work with cages, right? So we have these love cages, but them escaping there, it's usually just kind of 1 or 2 flights that really happen. Usually you should be monitoring kind of your cages to ensure that there's really no holes, but you don't have this major issue. However, this is still a part of research that is still being investigated, since it is a new question of understanding, will it affect the ecosystem if we had a huge outbreak? At the moment, I do not know of a huge outbreak that has happened and maybe altered the ecosystem, but we do know that they are already anyways present natively now within the tropic regions. So it's not as much of an issue there as it would be here. But I also want to make note that even in Switzerland, I mean, it gets very cold here. We're right now in winter. So they wouldn't really survive, right? The eggs wouldn't survive within these type of temperatures anyways. But usually there are systems in place in order to avoid that.
Thank you, Dani. We will hear from practitioners, and I would like to ask Mwangi and Jovita also to answer in your presentation this question. But I also would think, from my understanding of BSF, their behavior is that they actually are around fermented waste only. So they will really not go far from the substrate,
Yeah.
But that's my understanding. I wanted to show you also to everyone here, because Dani, you showed many photos, and we all believe that we like that those photos. But I also brought for you, everyone here, some samples. If you can see, this is dry BSF larva ready to be mixed with.
Maybe just put it further up, because you're blurred, makes it difficult to kind of see.
Yeah. Difficult. Oh, and like that now.
There's perfect.
I don't remember from where they come, because I visited many farms, but they might come also from Mwangi facility in Nairobi. So this is the larvas, and this is the frass, and it doesn't smell bad at all. Actually, it smells beautiful. This is frass. So this is the residue of larva that you put into soil as a soil improver. It's very nutritious in NPK. Voila. Okay. Moving. Okay, maybe there are a few questions. Thanks for them, but many of them also relate to practitioners and are also a larger discussion point. So I would move now to Mwangi, who is from Nairobi and is operating also one facility there. And we will come to all the questions and during the discussion session. So thank you, Dani. And Mwangi, the floor is yours. Your microphone is cut. No, it's on mute. Yeah. Not yet.
Sorry. I hadn't realized that I was on mute. Thank you. I'll not get back to much of introduction. I'll just mention that I've been doing BSF for the last 6 years, both small scale and commercial scale, through different models. So in my work, I've come across quite different challenges. And I would like to talk about the challenges that BSF farmers in Kenya and to a large extent East Africa, because I've also actually worked outside Kenya, face, and what are the practical solutions that we do apply. First of all, I've hosted a lot of farmers. I've lost count. Could be over 200, probably 300, I don't know. Yeah. But every time I meet a farmer, the first question I ask them is, why do you want to grow BSF? Because then that defines the approach that you may take. There are farmers who want to do BSF based on the fact that they want to just manage their waste. So like somebody growing, maybe who is rearing pigs in an urban area, or rather in a congested area, and the neighbors are on their case, like your pigs, like this area is so smelly, can you do something about it? And for them, their incentive is just to manage waste. There's someone else who doesn't have the waste, and they're looking at it from purely like let's say somebody is keeping maybe pig, chicken, or they just want to grow BSF and produce animal feeds and sell. So those are two different scenarios. The person who is managing waste, the question you'll ask is, do you have space to do, like, to set up, what space do you have? Are you going to go vertical? Are you going to go with the other model whereby you just go, instead of going vertical, you go, you just need, you don't stack the trays, and you expand based on the size of land that you have. So that then guides, like, if somebody just want to do to manage smell and they don't have space, they would go with the decentralized model. And here are the challenges when you want to grow the larvae yourself. First of all, if you just want to manage waste, then you are better off probably buying the eggs, or in this case, neonates. I'll not get too technical, so I'll just call them baby larvae. Sorry for those of us know what neonates are, but allow me to use baby larvae. So they just buy baby larvae and grow it. But for someone who is looking to do it from a commercial perspective, to produce the frass, which is the organic fertilizer, and the larvae, they'll go to, probably it's advisable for them to do a centralized model whereby they do breed and produce the eggs themselves, they hatch the eggs and grow the larvae to the end. So, and in that question, I think I already answered the first challenge that most people face, which is waste. So number one is waste. It's ridiculous when we think that waste is a challenge, but yet when you're doing BSF, especially if you want to do it from a commercial point of view, not just to manage your own waste, you can't seem to get enough. So like you find getting huge quantities of waste in one location in the clean form can be a bit difficult. By clean form, I mean waste which is free from inorganics, plastics, metals, and glasses and other inorganics, baby diapers and such. So that can be a bit of a challenge. Yeah. Yes, can see someone raise their hand. I think I'll address that. Yeah, so that can be a bit of a challenge to most farmers if you want to do it commercial. If you're having to transport waste, let's say like 20 kilometers away from where you live, the cost of transporting the waste only already may not suit in your financial model. And for those who want to do like BSF from a commercial perspective, then definitely they want to develop a financial model, because if your costs are higher than what you can sell it for, that becomes a challenge. Now, let's assume you've got the waste. In this case, we're talking about people who want to do commercial, not just to manage their own waste. Let's say you've solved your waste problem. Maybe you live near a landfill or dump site whereby like there's so much waste and it's readily available to you for free, and you don't have to transport it over long distances. Then the next question becomes replicating the results. You find that if you're not like replicating the results today, today you get maybe 1 kilogram of eggs or 100 grams of eggs. Tomorrow you cannot gain 10 grams of eggs. then your production becomes really tough for you and becomes more of guesswork. So, and how do you replicate, make sure you're replicating your results over and over again? First of all, when you're starting, you may not have so much data that you've collected from your facility. Each facility, or rather each farm, is a bit unique based on the environment. Even just here in Kenya, the environment at the coastal area, let's say Mombasa, is not the same as someone who is growing BSF in Nairobi. Like Mombasa is hot and humid, Nairobi is a bit dry and cooler. So two very different environments. And if you just go and do plug and play, you visit someone's farm in Mombasa, and you want to come copy the same in your locality, you may not get the same results. So replicating the results means, first of all, you'll depend on the theory. They are the basics. They are those basics like Dr. Daniela mentioned, like the temperature, and those are readily available. Temperature of up to 30 degrees Celsius. You find a way of maintaining those temperatures to that range. For us in East Africa, we don't have so much of a problem. Like our weather is not really so extreme. Then the next step is, when you get that data, you need to start analyzing that data. Like there are what we call conversion ratios for every stage. You need to know how many pre-pupa, or rather pupa, do I need to get a certain number of flies? How many flies do I need to get a certain number of eggs? Once I have these eggs, how do I need to hatch them for me to get certain quantity of baby larvae? Based on the feed stock that I have, because I saw a question about how about the quality of feed that we're using. Different feed will determine your feeding ratio. If you're by this case, by feed I mean the waste. Now at the point whereby we are feeding the larvae, we no longer refer to it as waste. We are referring it to as feed. So based on the feedstock that you have, like let's say pig waste, fresh pig manure, it's more nutritious than chicken waste. So that is going to determine how much are you giving per larvae, and you need to be measuring that. So major thing for you to replicate is that you need to collect the data as you go on. It's going to be a learning process. There are those basics that you can start with. And over time, based on your data, again, you need to set like certain conversion ratios. You know, based on whatever I've had in the past, once I get 1 kilogram of eggs, I'm getting this number of neonates or baby larvae. And based on that, and based on the feed that you have, you kind of have to do applied experiments for you to determine which feeding ratio gives you the optimum in terms of the cost of waste. If you're incurring some cost in waste, it's very rare for you to find somebody who is not incurring cost in waste. You need to look at how much are you getting the waste at. Secondly, how much is the labor, because also that determines the model that you use. Like the crate model is a bit labor intensive. May work in some areas, but the advantage is that if you are working with limited space, that works well for you. So it's all several different factors. So replicating, you need to collect the data, analyze the data, and set targets. Set like key performance indicator. When you know, like if I'm below this, then I'm probably losing money. Number 3 challenge that farmers are facing in East Africa is there's generally lack of technology, but that's a global thing. It's not just for East Africa. There are no like turnkey solutions, and most of them, the turnkey solutions which have been developed, basically. Can you hear me?
Yeah. Which solutions? Turnkey? I didn't get it.
Okay, but yeah,
turnkey. Okay, yeah.
So like there are no plug and play solutions, and the ones that are there, most of the time you find that companies selling BSF production technologies, they do oversell. They're really good at marketing, but when you apply them in your case, you may find that it's not working for you. So in most cases, you're forced to develop solutions for you. Case in point, like dryer. When you go to like milk production, when you're producing like milk powder, globally the standard way of producing milk powder is through using a spray dryer. But for larvae, there seems to be still a lot of conversation. There's micro drying. There are different dryers, but that's something that you need to design, because if BSF is around 70%. The larvae of black soldier fly around 70% water. If you're spending so much on drying, as much as you may have got the waste for free, and you used a model which is very labor efficient, then you may find that you're actually losing money on drying. So that is something that is needed, like you need really to consider. If you can get a dryer that runs on waste, like waste biomass, that would be really great for you. There are companies which are using heavy furnace oil, but again, you need to do the math. How much is the drying going to cost you? So lack of technologies is a bit of a challenge, and most people are struggling with drying and breeding. When you consider breeding, but breeding is more because of like not collecting enough data, like what I just mentioned. If you're not replicating your results, you're not collecting enough data, you don't know how much pre-paper you need to give you a certain number of flies based on your localities. From the flies you get, you don't know how much eggs you are getting. From the eggs that you're getting, you're not able to calculate the number of neonates that your hatch rate. Then it becomes more of guesswork. So when you're building the facility, you need to develop around both systems, or rather three challenges: waste, systems to replicate your production, and number three, you need to look at technologies, especially drying technologies. Yeah.
Thank you, Mwangi. I will stop you here. We'll come back, but a lot of very interesting practitioner points. So I ask everyone, take note what Mwangi say and get in touch with him for practical questions as well. I take from your point one important element, that we have to monitor and measure the progress, to not to repeat the mistakes all the time. So a kind of data collection and improving it. And I know that Chanzi, you also, your other company is also managing the data quite well by having this this tool. There are a few other tools available on the market to calculate, the substrates and so on, to have, depending also for what purpose. Yes, there was something else I wanted to say, but I forgot now, but it doesn't matter because I think we can move on to Jovita. By the way, I don't know what I wanted to say. I see that the topic of today, which is black soldier fly, is also around in your room. So great to see. We have them because you are at the farm right now, just in the office. So we see that the black soldier fly are not very much annoying, even to give a presentation. But Jovita, over to you to share your perspective from Asia.
Yeah, thank you, Piotr.
Thank you.
Good night, everyone, from my side. So I will start to share my screen here. Is it already? Okay.
Full screen now. Yes, great.
Good.
Thanks.
Okay, then. Okay, good night, everyone. So tonight I will share mostly about the experience to set up a BSF in Indonesia, together with who is the actor, and also what's the challenge of the collaboration that's also affect to the BSF model that you will develop in the site. And this is a glimpse of Pro BSF. Basically, we stand for Product Organic BSF, and we already established since 2019. We are focusing for BSF consultation and also BSF site development. And at the time also, we sell the refining product from BSF. And our business also collaborating with Project Forward, which is also under AOAC, that have a collaboration with the PUPR Ministry and also funded by SECO. And here, I just want to give like a short, explanation that BSF model will affect to your size range, and also the conversion rate, and also how the BSF model will be developed. So as far we experience to develop a BSF site, there is a collaboration between community, government, and also private partner, and also pentahelic collaboration that I've been doing so far. So if you have a collaboration with the community, usually the size range is really low, below 100 kg of waste treated per week. And the conversion rate is quite good because when the size is really low, we can really put attention to the waste substrate. And then mostly the waste treated, if we have a collaboration with the community, is the food waste from the household. And if we have a collaboration with the government, usually we develop a BSF that have integration with the TPS 3R, like it's a period disposal before go to the landfill, and the size range about 100 under 500 kg per week. And if you see here, the highlight of this slide is the partner, if you want to develop a BSF, really affect to your BSF model. So here is the centralized site, as Daniela mentioned. So we have developed this with the Project Forward and also AWAC as well. So we developed two centralized site that we do all the process of BSF, start from nursery until we do the post-processing, but mainly focusing on the nursery and also waste treatment. This integrated with the TPS3R here, and all the system here developed by IAWAC as well, that we use the LC and DC, which is maybe different with other BSF farmer in Indonesia. It's a loft cage and dark cage. Usually another farmer, they use a system like insectarium, so they combine the loft cage and also dark cage. But if you see here, the challenge is because the waste come from the TPS3R, there is a still mixed waste. So there is still a lot of plastic, and the worker needs to separate, and also they use the conveyor belt, but still sometimes still mix. And then from
Yovita, one question. What is TPS 3R?
TPS 3R is kind of like it's a disposal station before go to the landfill. In Indonesia, we have a lot of them to reduce the waste sent to the landfill, basically. Yeah. So here how to run the decentralized and centralized site. So from the centralized site, we send the baby larvae. We call it 5-day-old larvae. If you see here from the left corner, we just send the baby larvae with this plastic bag and then send it to community. Here we have a collaboration with community directly, which is really a small space that we want to prove that only small space you can also develop a BSF set, and it's already successful until today. So all the household have a schedule that they need to bring their own waste from their own kitchen, and sometimes they also add another waste like a coconut pulp or also the restaurant waste nearby their household. So if you see here, it's mostly is the house mother run this operation that they do the waste shredding, and also this is how they set up. There is like a drawer, like a rack here. So we put the name of the household and also the number of house. They need to responsible for each box. So after we set up the waste, we also do the feeding and also do the harvesting, and they also develop like a small pond with the catfish. So some of the fresh larvae harvested, they use it for to feeding the catfish, and some of them they sand fry the fresh larvae into the dried larvae, so they can sell it and then save for longer period. And then here also another model that we work together with the community, but here we don't work with the community directly. We just work with the garbage picker directly. So his name is Patata. So he transport the waste from the household, and then also we have a collaboration with the small our mini cafeteria nearby this site, and also in this site, Patata has a pond, of tilapia and also catfish, has a chicken and also a duck. So he willing to have a BSF site there, and then directly feed the larvae to their chicken or duck. So how this model can be run? So first we do the socialization to the cafeteria to collect their organic waste, and then we distribute free a bucket waste that for to collect their organic waste, and then Patata share their waste, mostly the same with other setup. And then this is also another model that we developed with the city government, that we work together with the cafeteria as well, but integrated with the TPS, like a small disposal before to the landfill. So basically all the process is the same, but the scale is still low. So the community side, we get the baby larvae from the central side. And here also another practice that we develop a model, have a collaboration with the private company, which they have a focus to transport the waste, and also they have a collaboration with the university. So this site developed close to the university, and then the university have also produced a waste, right? So this company get funded from the university and then collect all the waste from the household nearby and also from the university. And now this site still running well, and then they develop their site by selling the larvae to the farmer, like the catfish or maybe the breeder. And here another model that we also work with the government. Basically, this is the EWAC site in Sidoarjo, East Java. So this site treated organic waste, especially is the fruit and vegetable waste. If you see here, there's a lot of waste from the market. So this site located inside the market. So this site really rely on this market. So once the market getting lower the supply, this site also lower the production. So maybe this is also the challenge is if we work with the government. So before we work with the government, we also need to find a backup and also do the waste mapping to find another waste. And also it's already did by the private company. They already transport the waste from other source, but then this site already take over by a private company. So maybe the challenge here, we need to explore another waste sources nearby this site, not really rely on this market. And then we also have a collaboration with the fruit industry. It's a pineapple company. This site really well developed until today. So on the top, they start the setup with the EWAC system with the crates, and then once they already done with the research, and because they just only focus for the fertilizer for their own plant, they don't really care about the larvae. They just take the fertilizer, and then they once they already see that the BSF can be a solution for the fertilizer, so they now already upscale their production, and then change the model from the crates, and then they use this bigger rack like this. And also from the loft cage and dark system, they change into the insectarium because there's a minimum operation and then minimum worker to do these things. And also there's a collaboration as well between private company and then the food company. Like we treat the expired milk, we treat the expired biscuit like biscuit baby, and then also have a collaboration with the local market. At the beginning, they have a collaboration with the fruit, with the market that really produce a lot the fruit and vegetable waste. But it turns out that this conversion rate really low, where the substrate is really wet. And then we have a collaboration with the food company that bring nutritious waste, so can make the conversion rate better. And then another collaboration we did with the palm oil company. So basically, this can be a great model because with the private business, we always get the guarantee about the waste supply. So here we treat their decanter cake for the solid waste, and also we treat their liquid waste. It's a pome, we call it pome. But then the nutrition of these two ways is not really that good. So we also need to mix with other ways. Here, the white waste here, it's a wet cassava. And then we also mix with the palm kernel meal. And then we also have a collaboration with the market, but we have a system to buy the waste from the market, like the banana or maybe with the coconut pulp to increase the bioconversion rate. And this is also another setup. If you see here, the one layer system is the most famous system in Indonesia with to the BSF farmers. So most of the BSF farmers in Indonesia really familiar with this one layer system. So they just they don't use the rack, they just use one layer system. But in the city, if we set up a BSF in maybe in a bigger city, this might a problem. So they also changed the system from one layer into multi-layer with this rack. This rack also different with the AWAC system because it's already automatic stack. So we don't need to move it manually. And then this is the pentahelix collaboration because there's a lot of partner engaged in this collaboration. So we have from the academic, we have the we also have the researcher, business, also have a media, government. So all the partner engaged in this collaboration. So but then the challenge is also about and that we need to really communicate what part we will take in this collaboration, and also sometimes still overlap to each other. But then it's easier because it's already complete each other. So first in this collaboration, we need to do the campaign. So to distribute this free bucket to the community. And also we collect waste from the food company and also the market nearby the site. And this is the last collaboration that we did in Bandung. It's a pentahelix collaboration as well with the university, but still running really low because it's the fact in Indonesia we really difficult to get the waste, especially if we work with the household. So here we really do the we really approach the community to get their waste, but still a challenge to get it stable. So we approach the fruit stall nearby the site to get more waste to the site. So if we can conclude that the operational issue basically in Indonesia that we face so far is first lack of capital, because this is really a fact that if the BSF farmer wants to have upscale, it will and then the production also wants to get up, but if the capital is not enough, so they cannot do that even though there's a market available around. So market also access also a challenge. So so far we have a collaboration with the community. That's also the biggest challenge with the community, because it's like a communication barrier, and also from the farmer into the larger market, they need someone to be a bridging them each other. So pentahelix collaboration maybe can be a solution for that. And then unstable organic waste supply, either for quality and quantity, also an operational issue. As the Daniela also mentioned at the beginning, that the nutritious waste is the important things to the larvae, so they can grow well, and then we can get the best conversion rate. Next, it's improper site management. Why? Because sometimes a good site also can be collapsed because there is no site manager that can well manage the site. Because sometimes Indonesia mostly they still think that this is a service minded. So waste transportation is like a service minded, not a business minded. So sometimes they don't really think about the business. So sometimes the financial part's not really is really developed well. And then limited land and labor. So this is also because the land in here is also a bit expensive, and then this also related to the lack of capital. Next. Okay, so BSF challenge. Yeah,
Okay.
there's a
Yeah,
5 challenge, if you can see here. First, we need to ensuring a constant and sufficient waste supply. And then we need to challenge also high capital and operational costs, because BSF here in Indonesia still need a big OPEX. And then public perception also about BSF, they still think that BSF is a yucky insect, and also about their knowledge about BSF still low. And then ensuring a constant BSF nutrient quality as an animal feed ingredient to maintain product quality. This is if this will happen, the challenge, if the site already do the post processing as well. And then although the high price of BSF compared to fish meal, also still a challenge in Indonesia. So that's it from me. Thank you.
Thanks, Jovita. So interesting, and I don't know the region so well, so all those new collaboration elements were very interesting, but also applicable. Really, I find it that my lesson is that you always have to see which model works best. Yeah? And there is a variety of models, a variety of partners, city authorities, universities, households, as you work with TPS, also so household waste. The same I know in Nairobi, you know, with Taka, which also brings you waste close anyway to your facility, so the transport costs are. So there are ways to optimize the costs by applying different business model. And then they also mentioned the decentralized model of centralized for breeding, eggs production, and decentralized for growing larvae actually. So this is also a model that is very interesting to see that is happening, and it's about the choice. And indeed, within our foundation and with Daniela, with Stefan, who's also on the chat, with Bezawit and Jean and others, we are working to help the new farmers, the farmers who want to expand or to start, to actually identify the location and see which model works best in which location, because it's not copy-paste, also as other colleagues said today. So the analysis before you start is good. And then the flexibility to pivot and adjust, right? Like in one of your examples, you also adjust in the process. So it's never a fixed situation. So the webinar is actually 1 hour and a half as is planned. So, so please stay, because we'll have more discussion now and questions. But I also have a few colleagues with whom I work closely, and I wanted to ask now the perspective from West Africa, from Arthur, from Côte d'Ivoire. We also have some colleagues from Côte d'Ivoire and from Nigeria here. So if you can unmute Arthur and just in 1-2 minutes, really it's very short, express your situation in that region. Côte d'Ivoire, Ivory Coast.
Hi, hello everyone. Thank you very much. So a lot has been said in Western Africa. So we've been working on the field for the last 3 years. I think it's a bit the same as everywhere. And as it's been mentioned before, it's not because it works in Ivory Coast that it will work in Kenya or anything. Black soldier fly is different everywhere and it feeds differently. For the last few years, we've been working on different models. The one has been shared before, so centralized and decentralized. And for me, there's two main challenges that can evolve from it. It's the decentralized model is a very agile model. It's the one that I really appreciate and works very well because it's low tech, very easy to develop. And because in the decentralized approach, what's the hardest thing to do is to do the eggs. So if you have a special, we specialize in egg producing, and then we provide the eggs to the other farmers because fattening the larvas, it's pretty easy. And it's been done with the chicken, with the pigs, with everything. So this is something that can be replicated very quickly. And I believe that Black Soldier Fly addresses informal markets because we've seen it from the COVID and everything. All the people that doesn't have access to products that come from abroad crashes during those crises. And fish meal is expensive. Soil stimulation with fertilizer is expensive. So for me, it really addresses those small farmers that are making 60% of whatever we can eat in the Ivory Coast. And this is why I believe that the decentralized model will work very well. And in the centralized model, we've seen it during the last few years. It's very costly. Machinery has to come from abroad because making them locally, it's not the best. They don't have the best technology to do it, and it breaks a lot. So in the time, it costs a lot of money. And what we've seen is that the protein made from the larvas is not a big competition from protein made locally like fish meal or soy meal. It's the frass where the business is. And this is why in the decentralized approach, where we've added another value, we've added the value, we've added chickens around the farms to produce eggs, because this is where you get money out of your protein, is by producing something else, pigs, chickens, and then selling the frass or putting it in the field. This is what I wanted to say for my part.
Thanks, Arthur.
I
Thanks.
just
This is
wanted to
already...
add something.
Yeah, okay.
If I have 2 minutes. Yeah.
No, half a minute. Yeah.
Yeah, half a minute. So you've talked earlier about the fly escaping. So what we've seen on the field is that it's very good actually. If you have a few flies, it's not science. It's just that it brings other lives, like other birds. So it feeds the birds. If you have a big community of birds coming into the field, it would eat the other pest animals. So you need less chemicals around the area of the larva. So
thanks.
I had 2 minutes.
Yeah. Arthur, excellent. Actually, your last point is something for researchers to take on, but your practitioner view is also important, and I like it. Bringing biodiversity. But super. Also, the market conditions you mentioned and the resilience. Yes, the BSF seems to be a resilient way to address our trade and market barriers that are value chains. The synthetic fertilizers are becoming more and more expensive, and also they are not sustainable, and proteins as well. So, right, very, very, very interesting. Thank you for your view. I would like to ask a colleague from Uganda, Konstantin. I know you had maybe problems to connect, but if you are around, how is it in Uganda? And you have an interesting case. I visited your farm. By the way, Arthur, I also visited yours. But in Konstantin, I don't see Konstantin. So if we can come back, okay, we'll check. But Tapas, I haven't visited your farm. No, because it's too far. It's in Cambodia. But how is it in Cambodia and in India? Because you also know that market very well. Tapas.
Thanks, Peter. Hi, everyone. I'm dialing in from Cambodia. I think what I would say, this fantastic session, by the way, situation here in Southeast Asia is kind of very similar to what Yuvita already mentioned. In Indonesia is there. In terms of waste, there are different kinds of streams that you can use. For example, we currently are focusing mostly on market waste as well as spent grains. And these are both pre-consumer waste. And at the same time, there are some other companies in, let's say, Thailand and Vietnam, they are focusing on food waste. So all kinds of substrates, they have their own kinds of challenges, seasonality, bioconversion ratios, or FCR, whatever you may call. But at the same time, going back to what Arthur was mentioning regarding centralized versus decentralized models as well, it depends on what your final use case is. If your final use case is only about waste bioconversion, then yes, decentralized model is a much better option. But at the same time, if you are focusing on, let's say, feed manufacturing or larval manufacturing or the meal slash oil manufacturing, which is something that our focus area is, I think it's a mix of centralized and decentralized that makes more sense. So yeah, that's I'll not take too much of your time, but yeah, happy to answer any other questions.
Yes, thank you. And Tapas, also, I know you answered some questions in the chat, so thanks for that. You have a great knowledge. So please share your contact as well. Or you did. Yes, Konstantin not around, but Konstantin has interesting model to also there. Maybe Daniela, at some point, you also need to touch upon that using, for example, because I know you work with Konstantin, using the, how we call it? Water hyacinth, which is an invasive species also, and testing that one, you know, to feed the BSF. So interesting. But let's go to the questions. But my colleagues, if anyone of you want to address already something, please go ahead. But question, thanks to already for answering some of them live. Okay, there is one question on economics. It's from Alex. It's about the cost per ton of waste processing for BSF compared to composting at middle large scale. I think this is very location, dependent. But if anyone wants to answer that, I know Tapas, you are economists. You are an economist, right?
I could put in my 2 cents, but as you rightly mentioned, it is very much dependent on the jurisdiction. Like, for example, how exactly is the whole waste management industry there? Like, what kinds of tipping fees, what kind of service fees, etc., are there? So, and also when it comes to waste processing, you have to be very careful about what stage or which stage you are able to get the waste access to. Once the waste has already got mixed with different kinds and it has become the status of MSW or municipal solid waste, it becomes very difficult and costly to actually segregate it. Like typically in Indonesia and Southeast Asia, the proportion of organic waste in MSW is between 60 to 70%. Compared to India, it is like 65, very consistent. So it becomes very difficult, and then the cost dramatically goes high, and it becomes almost non. It does not make sense to actually do it at that level. But if you're able to collect it before it reaches the landfills, which is something that we try to do when in collaboration with the waste processors, then we have seen that the unit economics can work, but only and only if we are able to do it at a medium to large scale, not at a small scale basis. So it depends on geography. So
Geography and the scale, indeed.
yeah.
There was questions whether whether FRAS can be enough to sustain the whole model. No, possibly no, because the proteins, so the larvae, have a demand on the market. But wanted to ask, other colleagues, Mwangi and Daniela, on this question, of profitability and FRAS, actually. Because Vita, you also said at some point that one company is dealing only with FRAS, so they actually don't benefit from larvas at all. So does it hold?
Yeah, so I'd
Whoever
like to
wants
respond to that, Piotr. Yes, FRAS can be like production of FRAS from BSF on its own can be sustainable as a bit like from an economic point of view, but that will depend on two factors. First of all, the moisture level, the moisture content of the feedstock will determine a lot. If you're getting like say watermelons as a source of waste, basically you'll be transporting a lot of water to your production facility. So yes, based on your substrate, and secondly, based on like I mentioned about measuring like what you call the maybe key performance indicators, like for you to replicate those results. One of them is what ratio of FRAS are you getting per input? So you get the output divided by the input, like the output of FRAS that you're getting and over the input. And that, from that perspective, you need to, so the major cost is the cost of the input. But again, there are those operational costs which you have to put in consideration. So what I would say, like, is the best practice is don't look at it just from a FRAS perspective, because either way you're going to get larvae. If your larvae can cover your costs, like if you get to like sale of larvae cover your cost, then FRAS could be your profits. Yeah, so it's like it makes sense, because either way, FRAS, you get higher volumes of FRAS as opposed to larvae. Like larvae you have to dry. If you get, like, let's say your conversion is, let's say, 20% of larvae. That means from every 1 ton, you're getting 200 kgs of wet larvae. But then you have to dry that. From 200 kgs, you get around 70 kgs. So you started with 1 ton, but the final product that you can sell is 70 kgs. But remember, larvae, you are selling at a premium price compared to FRAS. Most parts of the world, like I believe everywhere, you're going to find that larvae is going to be more expensive than FRAS. So FRAS, you get in volumes, you have more value in volumes, but low value in terms of price per unit. But for larvae, you're getting very few, like very low in volumes, but much higher price per unit. So I would say you need both. But yeah, it can make sense if your goal is to do FRAS. There are companies in Kenya who are doing larvae basically for the fertilizer, especially the large plantations. Guys like Kakuzi, I don't know whether you've heard them. It's a listed company in Kenya. So they are produced, like they're one of the leading exporters of avocado and other fruits. And they have so much waste. That means they actually need a lot of fertilizers because they are growing and they get so much waste. So for them, the incentive is FRAS, not the larvae. And what then they'll do is they have an MOU, or rather partnership, with an off-taker to do larvae. And then theirs is just focused on FRAS. I hope I answered that question.
Yes.
Well,
Yeah.
yeah.
That makes very much sense. So, but it's also about optimizing your costs and benefits. You will not throw money away, but use it. But for that, you might also outsource some, or like create a sister company who will focus on that. Yeah. If any of the colleagues also, Daniela, please come in, or Jovita. There was okay. Daniela,
We can address.
Is it okay if I address another question that I saw in the Q&A?
Absolutely okay, Daniela, please.
Good. Okay, super. I saw one for everyone to know if you isolate the microbes associated with the substrate feed on by the larvae, will this quicken the process of decomposing the organic matter? So just to answer this one, it really depends on which bacteria or fungi you're maybe working with. So the literature has shown kind of mixed results on this, and it also depends on the substrate that you're working with. So for example, and I'm happy to also link some of the papers later, but we've seen that some bacterial strains, for example, when you add it at the same time that you're adding your larvae, so kind of this co-treatment, some showed kind of positive increase, some showed not so much. There was another study, though, that showed, for example, when using a fungi for banana peels, I think it was fungi for 7 days kind of pre-treatment. They found, I think it was like a 32% increase in fresh larval biomass. I have to double check that, but it just goes to show it depends, one, what the bacterial strain is or the fungi strain is, and also what substrate you're using, and also if you're, kind of doing it as a pre-treatment, so for many days before feeding it to the larvae, or if you are doing it at the same time. So happy to link that, but just kind of the research hasn't shown yet a clear answer on that. It's very substrate and strain specific.
Thanks, and thanks for your work in research, because it seems very complicated issue. And as the survey in the beginning showed, yes, the technology works, but it can be optimized by all those little elements, of mixing different nutrients, adding different elements that can further improve the digestion of metabolism of larvae, right? And make it safe.
Exactly.
Make it
exactly.
safe. There is a question.
There are some questions for
Mwangi,
me.
I will move to you. I have a question to you because the one from Rocio from Bolivia, that one about.
The one from
Actually, go ahead with
Rodriguez.
Yes.
From Bolivia. I would like to respond to that. So what you have observed is that household waste, if you can get household waste, it performs really good because someone throws a piece of fish, their garbage bin, piece of bread, so it tends to have a little bit of more balanced diet. But the other thing that we've also observed is that aeration of the feedstock really affects how much you're able to get, like in terms of the larvae size, or rather the growth rate or the conversion of waste to larvae. We find that when we have dispatched feed which is waste which has been grinded, even if it's household waste and it's been grinded, all of it looks like a bit of a slurry. You are not able to get as high conversions as when you do a blend of both grinded and like ungrinded waste. In nature, like BSF, they don't find waste which has been grinded. They just maybe feed on a carcass or like something of the sort. So if you're not able to get organic waste, or rather, sorry, not organic waste, household waste, which is like really diverse, has a bit of protein, fats, carbohydrates, you can look at aeration like as one of the things that you can do to get a higher conversion. So it's just a matter of like diversifying sources, like, but mostly if you get one stream and it's nutritious, like slaughterhouse waste is really nutritious, like you find undigested feed in there. The other question was from Irumba.
Yes, I wanted to ask this one to Jovita, if I may. So as a practitioner, there is a question that Irumba from Uganda, he has a problem with houseflies infestation. Do you have this problem, and how you addressed it? He covered the pond, but then he has issues with humidity and airflow. So if you can answer this one.
But thank you, Piotr. But in Indonesia, we don't face this problem, because we use the insectarium and we really keep the flies inside in the insectarium or the loft cage or dark cage. But then we also sometimes face a problem that the larvae intervention to sometimes they can crawl out, right? If the substrate is really wet, the larvae can crawling out, and then that's also the problem that we face here, not the flies.
Okay, not
So,
the house flies. So I will bounce it back to Mwangi.
Just need to just need to make sure that the mesh size range mesh size is really fit to the flies, so the flies will not going up to the environment.
Okay, and never use the mosquitera, because mosquiteras are indeed treated. So okay, Mwangi, about the houseflies. So next door to Uganda.
So for us, we've had that challenge before, but what we learned is mainly the key factor for houseflies is wrong feeding, the stocking density. That is, if you are the ratio of substrate to neonates, or the 5-day-old, 4-day-old larvae, depends on what you use, is too low, then you're going to have houseflies. First of all, houseflies, they thrive in anaerobic environment, which is like mostly bad smelling stuff. There's not enough oxygen in there. So you find that houseflies will like thrive better than the black soldier fly larvae. But when your stocking density is right, you find that the feed, you don't even get a bad smell. Maybe from calling, maybe you can confirm that most of the time you're finding where you have so much larvae of the housefly, like that substance is mostly smelling poorly. So it's mostly a factor of aeration. The second one could be water. Like where you are growing the larvae, I don't know, like maybe if you're using ponds or polytunnels, when you're growing the larvae, you may find that the BSF larvae are feeding, but then when it rains, you're getting water there. Like, so that effect of aeration is reversed and you get an aerobic environment. So those are the two major things. Thirdly, the other one which I might have forgot to mention is at the nursery, where you are feeding the neonates to the point where they are 5 days old larvae or 4 days old larvae. is that area like protected from like foreign insects like houseflies? Because like you either get larvae, houseflies getting introduced at the stage where they are actually growing, the larvae are growing in the rearing area, or you find them introduced into the substrate at the point where like the neonates, the BSF neonates are not able to outcompete them. But at later stages, from day 5 to day 7, thereabout, you find that the larvae of the BSF, they do outcompete the larvae of the housefly. So you need to be very keen at the first stage at the nursery level. Make sure that no houseflies are have insect nets around. But then when you're transferring them to the rearing area or the bioprocessing area, then you just need to make sure that your stocking density is right. By stocking
Thank you.
density,
Mwangi, I have some indication we have to close, which makes me sad because it's very interesting. But your reply I like. So it's using, changing the conditions, adjusting the conditions naturally rather than using pesticides, because someone just suggested pesticides. No, but I don't think it's the case.
no, don't
Okay.
use pesticides. They'll kill the larvae.
Exactly. Okay. Thank you, everyone. We have to close now, really. But please, the recording will be shared in about 2 weeks from now or something like that. Yeah, Akanshka. And please take notes in the chat, connect through LinkedIn. We also see some emails, people sharing. Yeah, let's connect on LinkedIn under the post of Be Waste Wise, where this webinar will be shared, and we will continue probably with another webinar and some other activities. I thank you very much, Daniela, Mwangi, and Juvita, and also Tapas, Artur, for your inputs, and we shall continue for sure. Please join the community of practice on WhatsApp. This is a great way to further continue. We will actually organize further webinars within the community as well. It's for free. So yeah, as you see, research is needed to optimize, but the activities, the technology is there and it's thriving. Thanks to you guys. So thanks a lot.
Thank you so
Over to
much.
Akanshka.
Thank you.
Thank you, everyone.
Bye, thanks.
Bye.
As I mentioned, this webinar is being recorded and will be uploaded on our website. So please do watch our recording in due course of time. Please also check out our future events and webinars like these. You can subscribe to our newsletter and also look up on the Facebook, Twitter, and on our website and LinkedIn as well. So thank you so much to all the panelists for taking time out. As we can see, the chat function was flooded with comments and views and links for the attendees, and we are glad you all took active part in this discussion. Thank you again, and have a good day to you all.
Thank you.
Thank you. Bye.
Thank you. Thank you.
Bye.
Bye-bye. Sante. Thank you.